Hi everyone, welcome back to Life Technologies channel and thank you for watching. So today we are continuing with our Huawei Lab simulation series, and in this part 6 we'll be focusing on how to implement policy-based routing on Huawei routers. So we know the traditional way of router forwarding the traffic is by searching the routing table and determining the path to use based on the destination address. So if you are running a protocol like OSPF or SIS, the traffic will be forwarded based on the shortest path. So in case of OSPF and SIS, will be the path with the shortest or the path with the lowest cost will be used to forward the traffic. But then sometimes you need or you require control over traffic forwarding on your network. So what the policy-based routing is doing is it's giving the network engineer the power to control how traffic flows on the network. The network engineer can configure some custom rules on the routers and define the next hop for the traffic. And this one gives him the control, the fully control on how to forward traffic on the network. As you can see, this is the topology. We have PC2 and PC3, and then we also have PC4 and PC5 simulating the users on the network. And then we have the backbone network that is made up of 5 routers, R1, R2, R3, R4, and R5. So the target is to ensure that traffic that is coming from PC2 is using the upper path, while traffic that is coming from PC3 is using the lower path. Remember, without policy-based routing, all traffic will be forwarded via the upper path, because based on OSPF, if you have configured similar cost on the lower and upper path, then that one will, the upper path will have lower cost. So the traffic will be forwarded via the upper path, which is R1, R4, and R5. But then we need to control the traffic that is coming from PC3 such that it will be forwarded via R2, R3, and R5, which is the longer path. Maybe it's longer, but it has a higher capacity. So with policy-based routing, we are able to define some custom rules on R1, which will control the traffic flow of PC2 and PC3 when they are sending traffic to PC4 and PC5. So for the configuration part, first we are doing the basic configurations. So we are using OSPF on this network. And these are the basic configurations. We assign IP addresses on the interface as planned. You can see the IP planning. It's indicated on the topology. All the point-to-point IPs are as assigned. So once we've assigned IP address on the interfaces, we are doing OSPF configuration. And then we are advertising those networks, the respective networks that are configured on different routers, so that we are able to achieve end-to-end connectivity. So similar configuration is applied on R2, R3, R4, and R5. So once we've configured the interface IPs and OSPF, we can verify that our OSPF peerings are up. On R1, let me just do it on top of the topology so we can be able to see the topology. On R1, if I display OSPF peer, you can see we have 2 OSPF peerings, one to router 4 and another one to router 2. On R3, we can also check the same, display OSPF peer. So we have 2 peerings, one to router 2 and one to router 4. R4, we can also verify that we have the peerings, display OSPF peer. We have 2 peerings, one to R1 and another one to R4. So our OSPF is fully configured and it's running, and the routes are exchanged between the routers. So if we display IP routing table, you can see that we have routes coming in from different routers via OSPF. So once we have OSPF running and the routes are exchanged properly across the network, we can do traces and pings. On this PC2, I can ping 40.40.40.2. Remember, 40.40.40.2 is the IP of PC4. So it's reachable. I can also ping 50.50.50.2, which is the IP address of PC5. So if I do a trace from this PC to PC4 and PC5, you can see we are following the upper path, which is the traffic is forwarded to 30.30.1, which is configured on R4. I can do a similar trace, 50.50.50.2. The traffic is also forwarded via the upper path. If we do a similar ping or trace on PC3, you can see traffic is also following the same path. If we do a trace to PC5, the traffic is also following the upper path. So we don't have any traffic that is flowing from PC3 to PC4 or PC5 via the lower path, because this one has a lower cost, so it will always be preferred compared to the lower path. But then our objective is to ensure we can control the traffic flow using policy-based routing. So how do we configure policy-based routing? The configuration is simple. First, we need to define ACLs on the router. We are doing the configuration on R1. If you want to control the downlink traffic that is coming from PC5 to R1, then you need to define similar configurations on R5. But we are only doing on R1 and controlling our uplink traffic that is flowing from PC2 to PC4 or PC5. So this is how we define the ACLs. We are defining ACL 3000 and ACL 3002, and then we are merging the source IP addresses of the PCs. So once we've configured the ACLs, we can now specify our policy-based route. And as you can see, you need to specify this command policy-based route and you give it a name. And then you can do different nodes like the indexes. So the first part is merging ACL 3000. If it matches ACL 3000, we are redirecting the traffic to this output interface. So we are configuring this one as the output interface of traffic that is coming from this ACL 3000. Then we are creating another node that is merging traffic from ACL 3002, and then we are specifying the exit interface as serial 001. So from the topology, you can see clearly that if traffic is coming from PC2, we are specifying this one as the output interface, serial 00, and if it's coming from PC3, we are specifying serial 001 as the next hop, as the output interface for our traffic. So once you've configured the policy-based route, you need to apply it on the interface. So this is how we do we are binding the policy-based routes now on the interface. So the policy-based route and the ACLs are already configured on the router, but because we haven't applied them on the interface, they have not taken effect. So the last part that we need to do is to apply the policy-based configuration on the interface. So on R1, if you do display current configuration, you can see that we don't have any policy-based configurations on the interfaces. But from down here, you can see that we have this policy-based already configured as defined on the slides. So what we just need to do is now to apply the policy-based routing on the interface facing the PC, because we are merging traffic as it's coming in. So we are applying it on the interface that is connecting to the PC or the customer side. So once we've done this configuration, if we do display policy-based route, you can see the details. And now if we do a trace, we don't expect the traffic from PC2 to change because it will be flowing via the same path it was using. But if we check on PC3, we expect the traffic now to flow using the lower path. So if we do trace to 40.40, you can see the path has changed. It's now flowing via the lower path. If we do a trace to 50.50, it's also flowing via the lower path. So the policy-based route has taken effect, and now the router will not be forwarding traffic based on the routing table. It will be forwarding the traffic based on the policy-based route that we have configured. So if we don't have a policy-based, then the router will use the default path. For example, if we were to come to this router and then we do interface serial 0/0/0, we shut down this interface. From PC3, you can see that now the traffic is not going through because we have configured a policy-based route, but then the policy-based route, the interface is down, so the traffic is not flowing. That's why we are having, it's just getting to the gateway and then it's not going through. So we need to do further labs and simulate how we can control the failover so that once we have the policy-based or the policy-based is inactive, then the traffic should be able to flow just using the normal forwarding path. So this is just a basic lab on how to implement policy-based routing. We've gone through the configuration, how to define the ACL, how to define the policy-based route, and match the ACLs, and then you can apply the output interface. And the final part is applying the policy-based route on the interfaces, on the respective interfaces, and then they will take effect. And remember, this is the topology. We have PC2, PC3, and then we have the backbone routers R1, R2, R3, R4, and R5 that are running OSPF and the IGP protocol. So the policy-based routing will help us not to forward based on the shortest path, but to forward based on the custom rules that we have defined on the routers. And just to mention again that if you want to control the downlink traffic, you need to also configure R5 to be able to control the downlink traffic that is coming from PC4 and PC5 to PC2 and PC3. So it should be both directions. You control both uplink and downlink. So guys, thank you for watching again, and remember to like, to leave a comment. If you have any question, just leave your comment in the comment section, and remember to subscribe to our channel as we'll be sharing more interesting videos in our upcoming series. Thank you.